All right, folks, here's Perms and Comms lesson 1 on the fundamental counting principle. We're often concerned with counting the number of elements in a finite set. The elements might be different arrangements or selections. So the first thing we're going to do here is the OR situation. So the OR situation gives you a couple options. So in this first example, Jennifer's deciding what she wants to do. She can go to a movie or go to dinner, but she can't do both. All right, she's just got the evening to spend. So she can watch Super Troopers, Princess Bride, or Superbad. So there's 3 movies that she can check out. And then she's got 1, 2, 3, 4, 5 restaurants. So in total, she's got 8 options. So in general, we can say that there's m ways to accomplish the first task and n ways to accomplish the second one. The number of ways to accomplish one or the other is m plus n. Kind of makes sense, right? You can either do one thing or the other. You can't do both at the same time. So here's an example. We've got a single card is drawn from a standard deck of playing cards. Now, you need to know that there's 52 cards in a deck. You need to know that there's 13 of each suit. And there's 1 to 10, and then Jack, Queen, and King of each. That's like a common knowledge thing for this course. So a single card is drawn from a standard deck of playing cards. How many different outcomes of drawing a queen or a king? Well, there's 4 queens, and there's 4 kings. So if we add them together, there's 8. There's 8 ways to get one of those cards. A single card is drawn from a standard deck of playing cards. How many different outcomes of drawing a jack or diamond are possible? Okay, well, we've got 4 jacks that are possible, and we've got 13 diamonds. You have to be careful, though. One of the jacks is the jack of diamonds. So you're actually counting it twice. So what you need to do is you need to subtract that the double case, okay? So we have 4 plus 13 minus 1 gives us 16 ways. If you draw a jack of diamond, that kind of hits both things, so you can't count it for both. So in the fundamental counting principle, here's a couple more examples. This one is a little bit different, however, though. It says, in the school cafeteria, students must select one entree and one side. This is a little bit different situation. Their choices are as follows. They've got 4 entrees, 3 side dishes. How many different meals are possible? Well, if we draw a little tree diagram, so if the student selects beef for their entree, they can then select salad, fries, and pasta. Okay. If they select chicken, the choices are still the same. And then pork. And finally, tofu. Okay. So if we count this up, there's 3 plus 3 plus 3 plus 3 gives us 12 different meals. So the and situation, if we multiply the 4 entrees by the 3 sides, that's the same as drawing a tree diagram. So the fundamental counting principle states that if this task is made up of stages, the number of possibilities is given by m times n times p, etc., and they're the number of stages. So here's an example. Toy manufacturer makes a wooden toy in 3 parts. So you've got the part 1, the part 2, and the part 3. So part 1, there's 3 choices. Part 2, there's 2 choices. And part 3, there's 4 choices. So all we got to do is we got to take the 3, multiply it by the 2, multiply it by the 4, and you'll get 24 different ways of creating that toy. Determine the number of distinguishable four-letter arrangements that can be formed from the word English if letters can be repeated. So, for example, you could have, you could do E times E, or sorry, E, 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 E. You could do E, 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 N, so on and so forth. Okay, so you're allowed to repeat the letters. All right, so we've got 4 spots that we need to pick a letter. Now there's 7 letters in total. And so for the first option, we could pick any 7 of them. For the second one, we could pick any 7 of them. For the third one, we could pick any 7. And then for the last one, we could pick any 7. So if you multiply that all out, there's actually 2,401 situations of 4-letter arrangements from the word English. All right, so no letters are repeated, and there's no other further restrictions. So we still have 4-letter word. So for the first one, you got 7 options, right? You've got all those. So there's 7 in total. So we can pick any 7 of those. Well, if we're not allowed to repeat, for example, if we picked E, how many choices do you have left? So in the second spot, you got 6. And then, for example, if we picked L, then you've got 5 left, and then 4 left. So if things are not allowed to repeat, you have to subtract 1 from each step. So 7 times 6 times 5 times 4 is 840 options. Sorry, not options, arrangements. All right, the next one here, we're still not allowed to repeat, but the first letter must be E. So there's only one option there. So again, if we have all these letters to pick from, E's out of the picture. We're not allowed to repeat, but that's fine. So for the next stage, you can have 6, and then 5, and then 4. Now, you don't count E as a letter. You would use it as the number 1, because there's only one option. So 1 times 6 times 5 times 4, there's 120 ways. Okay. In the last situation, again, we're not allowed to repeat, and the first and last letters must be vowels. So we still have 4 letters. We need to create a 4-letter word. Now, how many vowels are there? There's 2 vowels. So in the first spot, we've got 2 vowels. Oops, I guess I can just write the number in. Got 2 vowels. And then how many consonants do you have to pick from? 1, 2, 3, 4, 5. So you've got 5, and then one of those is going to be used. So we've got 4, and then we only have one option for a vowel at the end because we've picked one of the vowels. So if we multiply all these numbers, there's 40 arrangements. Consider the digits 2, 3, 5, 6, 7, and 9. If repetitions are not permitted, how many 3-digit numbers can be formed? So how many in total are there? There's 1, 2, 3, 4, 5, 6. So there's 6 numbers. No repeats. So we're going to go 6 times 5 times 4. And that gives us 120 ways to arrange them. How many of these are less than 400? Interesting. Okay, so less than 400, we're still making a 3-digit number, but less than 400 means that it has to be a 2 or a 3 in the first spot. So we've got 2 options. All right, so it's got to be 2 or 3. Now, if it's 2, the next digit could be 3 again, or vice versa. If it's 3, the next digit could be 2. So that means for the next spot, we've got 5 options, all right? And then lastly, we've got 4. So 2 times 5 times 4 gives us 40 ways to do that. And what if they're even? All right, well, what are the even digits there? So you could have a 2 or 6. So this is kind of the same. Doing this backwards. If they're even, the last two digits has to be 2 or 6. All right. So there's two options there, and then 5 and 4. Okay, we've used one of the 6 numbers for the end. That means we have 5 for the first spot and then 4. So again, there's 40 ways to do that. Multiples of 5. Well, how do we guarantee a multiple of 5? Well, the end digit would either be 0 or 5, but 0 is not an option. So 5, there's only one way to get that. And then if 5's out of the picture, there's still 6 numbers, and then there's still 4 numbers. So that only gives us 20 arrangements of 3 numbers, 3-digit numbers, that are going to be multiples of 5. Car number plates in an African country consist of a letter other than I or O, followed by 3 digits, the first of which cannot be 0, followed by any 2 numbers which are not repeated. That's important. How many different car number plates can be produced? Okie dokie. So the first spot is going to be not I or O. Now again, something you just need to know is that there's 26 letters. Okay. So if 2 of these are not allowed, that means there's still 24 options. A, B, C, D, etc. Just can't be I or O. Okay, 3 digits. So we've got a number, a number, a number, and any restrictions on those digits, the first of which cannot be 0. So for this one, you've got 1 through 9, which means that there's 9 options. The second one, there's no restrictions, so 10. Is there any repeats on the digits? Doesn't say anything about repeating digits, so 10 and 10. All right. Followed by any 2 letters which are not repeated. So we can have any letter. So there's 26 options, but any letter not repeated. So if we've used one, that means that there's 25 other options. So if you multiply all this out, you get 14,040,000. 40,000. So I'm going to double check that on my calculator. 24 times 9. Yep, there it is. So we've got another license plate situation. A certain country has peculiar rules for its license plates. Each license plate has 5 characters. First 3 must be letters, such that the first and third letters are consonants and the second letter is a vowel. Okay, so there's 26 letters. A, E, I, O, U are vowels. So there's 5 vowels, which means that there's 21 consonants. Okay. All right, so 5 characters, so 1, 2, 3, 4, 5. First 3 must be letters, such that the first and third are consonants, so consonants, consonant, and second letter is a vowel. Next 2 characters must be odd, and no repeat for the last one. So let's fill this in. 21 consonants, 5 vowels, 21 consonants again, odd numbers, so 1, 3, 5, 7, 9, so there's 5 options. We can't repeat them for the last one, so one of them is removed, so only 4, and if you multiply those, it's 44,100. Allison, Braden, Ben, Ashley, and Amy are lining up for a group photo. How many arrangements are possible if Braden and Ben insist on standing on opposite ends of the group? Okie dokie. So we've got 1, 2, 3, 4, 5. 5 kids. So we're going to do a group photo here. Something like this, you know? I know my drawing skills are excellent. All right. So Braden and Ben are not best buds. So they have to be on opposite ends of the group. So this could be Braden or Ben. So there's two options. Now, if Braden's on the one side, Ben's got to be on the other side. So there's only one option for the end. And then we've got Allison, Ashley, and Amy. Doesn't matter where they stand. So there's going to be 3 ways to pick one of them for that spot. 2 and then 1. So if you multiply that out, there's 12 ways to arrange that photo. Okie dokie. Now we're going to combine addition situations with the fundamental counting principle. When generally the rule of thumb is when you see or, think addition. When you see and, think multiplication. How many 3-letter arrangements consist of only vowels or consonants? So this is addition. Right. So we've got 2 situations. Either they're going to be vowels or they're going to be consonants. All right, and we can add the 2 situations here. So vowels, again, there's 5 vowels. So 5 times 4 times 3 gives us 60 ways. And consonants, you'd have 21, 20, and 19. Which give us 7,980. So because it's an or situation, it doesn't matter which one we get. So if you add these 2, you're going to get 8,040 situations. Arrangements, not situations. The telephone numbers allocated to subscribers in a rural area consist of one of the following. The digits 345, followed by any 4 further digits, or the digit 2 followed by one of the digits 1 to 5 followed by any 5 further digits. Very confusing. So let's deal with situation 1. So the digits 345 followed by any 4 further situations. Well, there's only one way to get the first 3 numbers. It's got to be 3, 4, and 5. So 1 times 1 times 1. However, we're then allowed 4 further digits. Now, it doesn't say any repeats. It doesn't say anything about that. So it's going to be times 10 times 10 times 10. All right. Now, if we multiply that, you get 10,000 ways. And this is the first situation. Now, the or situation here is going to be the digit 2. So there's only one way to get that. Followed by one of the digits 1 to 5. So there's 5 options. Followed by any 5 further digits. And again, it doesn't say anything about repeats. So it's going to be 10, 10, 10, 10, and 10. So if you multiply that out, you'll get 500,000. And if you add those 2 situations, 510 different possibilities. How many, this is our last one, how many 4-letter words begin with the letter H or end with the letter N? 4-letter words. So we've got a H, begin H situation. And then there's going to be 3 words, 26, 26, and 26. Or end with N. So we're going to have 3 things and then ending with N. So 26, 26, and 26. All right. So let's multiply this. Yeah, we've got this first situation, begin with H and end with N. We have something to note though, but the words starting with H and end with N are counted twice. Okay. So we need to subtract that in the end. Okay. So how do we figure out the ways that the words starting with H and ending with N are counted twice. Okay, well, let's just figure it out. This has to be H. So there's one situation. Then it could be 26 options, and then the last has to be N. So this one comes out to 676. So this was 17,576, and this was 17,576. So what we need to do here in the end is to take 17,576, which are the beginning H ones, plus the 17,576, which are the ending N ones, minus the 676 cases that we've counted twice, and you end up with 34,476.